Okay, now we're up at the top of the 2.1 page again, and we're looking at number 12. And actually, there are a whole list of them here. And let's read the instructions. It says, evaluate the function at the given value of the independent variable and simplify. Okay, let's interpret. What the heck does that mean? Okay. That means, remember, the independent variable is x. They're telling me what x is, and I want to figure out what y is. Okay, now let's look at this. This is new notation for most of you. This is what we call function notation. So let's get out my handy scratch paper here. Function notation. Okay. F of x equals, and then I'm just going to make something else up. 5x plus 5. Okay. So notice what I said. We now use this special notation, some letter, usually F, G, or H. Those are our favorites. And then these parentheses with x. This does not mean multiplication anymore. Okay, so this has to be read in context. This now means something brand new. I say the words f of x. That is shorthand for a function of x, which it just means that x is the number I'm putting in. I pick my x's to find my answers, which we traditionally call y's. Okay, so that means if it makes it easier for you, you can take out the f of x and put in y instead. Those two things are completely interchangeable. Okay? Now, when you think about function notation, I want you to think about it as a fill-in-the-blank problem. So instead of f with the x in there, I could just as easily write f, and there's my blank parenthesis, is equal to blank parenthesis plus 5. And this is a fill-in-the-blank problem. Whatever's here by my f, they're telling you put this number into this piece over here. This function is what it's called, a function. So if they want me to find f of 2, that means everywhere I see an x, I should put a 2 instead, and then do the math. So I now know that f of 2 equals 7. F of 2 equals 7. Now this new notation means that if I were making an xy table, when x is 2, y is 7. That's what this notation means. So f of 2 equals 7 just means when x equals 2, y equals 7 in a table, or I could write an ordered pair of 2, 7. And that is the point that I would plot if I were graphing this. That's all it means. It's just new notation for something that you are already familiar with. Okay, so let's go back and do number 12. Here's my function. F of x equals negative 3x minus 7. Find f of 6. So that means I should have negative 3 times 6, because see, that's where the x is, minus 5. And now I do the math, and I get, let's see, that's negative 18 minus 5 is negative 23. That's it, I'm done. See, that's not so bad. Okay, let's do 13. Here's my function h of x. This function, or rule, is telling me take your input value, subtract 12, and then take the absolute value of that. Follow your order of operations. It is often helpful to say it in words. Take your input value, subtract 12, then take the absolute value of that. Okay? So let's write it down. Instead of x, I put 17, because I want h of 17, minus 12. 17 minus 12 is 5. The absolute value of 5 is 5. Done. Oh, could you even see that? Oh no, let me scoot over. I apologize. Okay. Let's look at 14. Same thing. Instead of x, I'm going to put in negative 4. So I'm taking the square root of negative 4 plus 13. Follow your order of operations. Negative 4 plus 13 is 9. The square root of 9 is 3. And notice there's no plus or minus in front here. It's just the positive root. This is just not that bad, right? I'll let you guys do 15. You do get a weird fraction. Please leave it in fraction form. Do not change it to a decimal. And now, this is where the fun starts. Okay, we definitely need our scratch paper for this one. I have here g of x is equal to 3x minus 1. And we want to find g of x minus 1. And you look at that and you go, wait a minute, that's confusing, because that's not just a number, Renee. We were talking about numbers. Okay, so let's look at it. There's my function, g of x equals 3x minus 1. So let's think about that blank parenthesis idea again. G of whatever I'm putting in there, my input, is equal to, let's say it in words. This function up here says take 3 times your input value and then subtract 1. Take 3 times your input value and then subtract 1. This time, what is my input value? Well, it's not a value, it's another expression. So this time my input is x minus 1. So I fill in the blank with x minus 1. That's what it means. That's what you have to do. Don't overanalyze. Now, just simplify. 3x minus 3 minus 1 equals 3x minus 4. And that's it. Instead of getting a value, a y value out, what you get is a new function. And what we're going to learn in section 2.5 is what changes. It's kind of interesting actually how the original function, if we graphed it, and then we graph this new function, how they're related to each other. Okay, but that's for section 2.5. So let's try, what's the next one? Ah, good one. 17 says, let's see, f of x is equal to x squared minus 1. So let's do the blank parenthesis again. F of whatever my input is equal to, now let's say this in words. This function is telling me take my input, square it, then subtract 1. Okay, take my input, square it, then subtract 1. What is my input this time? X plus 3. The expression x plus 3. And now I simplify over here. Well, I expand, let's say that. Okay. This is actually a very useful form. Sometimes we might want to leave it like this, but right now we want you to practice doing some multiplication. Don't forget, this means x plus 3 times x plus 3. So you should get x squared plus 6x plus 9, and then there's my minus 1. Okay? We simplify that, and we end up with x squared plus 6x plus 8, and that would be your final answer. You don't have to factor that again. You can if you want to, but I'm not going to require you to do that. Okay, so that is how we use function notation.